Hello, in this video for MAC2233, Calculus for Business and Social Sciences, we're going to be talking about section 6.2, Integration through Substitution. So, in this problem, we're taking the integral of 4x times x squared plus 1 raised to the 4.4 dx. There should be a dx here. So this is complicated. We have 4x being multiplied by x squared plus 1 raised to the 4.4. We have x squared plus 1 raised to the 4.4. And if we were doing derivatives, we'd be talking about product rule when two things are being multiplied, or maybe even chain rule when we have stuff raised to a number. But for integrals, we don't have that. But we can do something called U substitution. And the idea is to start with something complicated like this problem, and with the correct U substitution, put it in terms of U where it's simpler. So we're going to go through some examples and hopefully it will click, but really you just need to go through some examples and I'll point some things out. So again, we're starting with a problem that's a little difficult. The integral of 4x times x squared plus 1 raised to the 4.4 dx. So we're going to make a U substitution of x squared plus 1. I'll explain more why we chose this, but let's go through the process and I'll go back and highlight why. So when we make U x squared plus 1, instead of having x squared plus 1, we're going to put u raised to the 4.4. Now, one thing that's good about that is I don't know how to take the integral of x squared plus 1 raised to the 4.4 right now, but I can take the integral of u raised to the 4.4 by adding 1 and dividing by it. So it does make my life easier. So u is going to be x squared plus 1, and then to follow the process, we're going to take the derivative of u with respect to x. So the derivative of u is the derivative of x squared plus 1, the derivative of x squared is 2x, and the derivative of 1 is 0. So let me point this out because we're going to do kind of a shortcut later on, but we need to take the derivative of u, so we do the derivative of u with respect to x, du over dx equals 2x. But remember there's a dx here. I want to substitute in for dx, but right now it's du over dx. So du over dx equals 2 over 1. So if I want to solve for dx, this would be 2x over 1. We cross multiply. Dx times 2x, so dx times 2x equals du times 1, equals du. Then if we want dx by itself, to get rid of times 2x, we would divide both sides by 2x. So that would leave us with dx equals du over 2x, or dx equals 1 over 2x times du. So we decide what our u is, we take the derivative of u with respect to dx, with respect to x, then we solve for dx. Then we do our substitutions. And remember, the whole point is we're starting with something complicated, the integral of 4x times x squared plus 1 raised to the 4.4 dx, and hopefully it ends up with something simpler. So instead of x squared plus 1, we put u, and instead of dx, we put 1 over 2x du. So when we make those substitutions, we'll have the integral of 4x times u to the 4.4, that's simpler, times 1 over 2x du. So instead of x squared plus 1, we put u, and instead of dx, we put 1 over 2x du. Now, it looks like it's really complicated now because now we're dealing with x's and u's, and that's not what we want. We want to convert it to u, the letter u, and then it should be simpler. But if you take a second look at it, we have 4x over 2x. X divided by x is 1, and so the x's are gone, turn into 1, simplifies to 1. And then 4 divided by 2 is 2, so we're left with the integral of 2 u to the 4.4 du. Again, the point of this was we had something complicated. With the correct u substitutions, it turns into something simpler. Now, please understand, we just did the substitution, so now we're in terms of u, but we have not taken the integral. So to take the integral of 2 times u to the 4.4 du, the 2 stays in front. To take the integral of u to the 4.4, we add 1, which would be 5.4, and divide by it. So we have 2 times u to the 5.4 divided by 5.4 plus c. Remember, integral has a plus c at the end. But we don't want our final answer in terms of u, we want our final answer in terms of x. We turned it to u so it's simpler, but now we want to get back to x. So instead of u, we're going to put what u equals, which is x squared plus 1. So our final answer will be 2 times x squared plus 1 raised to the 5.4 divided by 5.4 plus c. Now that was kind of a lot, but let's review a bit. We had a complicated problem, two things being multiplied, stuff being raised to the 4.4, and then with the right u substitution, x squared plus 1, it became a simpler integral to u to the 4.4 du that I was able to take the integral and then go back to x. Now, how did I know that u is going to be x squared plus 1? This will come with practice, and remember, sometimes it just doesn't work. But when you want to pick the correct u, it should do two things. One, it should make your problem simpler. Then when you take the derivative, it should make it even simpler. So instead of x squared plus 1, I put u. Because remember, I don't know how to take the integral of x squared plus 1 raised to the 4.4. But if I turn that to a u, the integral of u to the 4.4 is something I can do. And we did. Also, the derivative of x squared plus 1 is 2x, and that 2x ends up in the denominator, and it ended up simplifying with the x that was in the numerator that was in the original problem. So x divided by x is 1, so that disappeared. It simplified out. So number 1, it helped me when I did the substitution, and number 2, the derivative also helped me to simplify the problem further. But again, let's do some more examples. So if I have the integral of x squared times x cubed plus 1 squared dx. Again, two things being multiplied, I have stuff being squared. What could I do? Well, if we did a u substitution where u equals x cubed plus 1, let's see how that would help. Number 1, I don't have x cubed plus 1 squared, it would be u squared, which is much easier to take the integral. And then our first step is take the derivative. So u equals x cubed plus 1, the derivative of u with respect to x, du over dx, equals, the derivative of x cubed is 3x squared, and the derivative of 1 is 0. So we'd have du over dx equals 3x squared. Well, we want to get dx by itself, so we do dx times 3x squared, dx times 3x squared equals du times 1, which is du. But we're trying to get dx by itself, so to get rid of times 3x squared, we divide both sides by 3x squared, so we get dx equals du over 3x squared. We'll be substituting in u equals x cubed plus 1, and du over 3x squared equals dx. So our original was integral x squared times 3x plus 1 squared dx. Instead of x cubed plus 1, we put u, and instead of dx, we put du over 3x squared. So we have the integral of x squared times u squared times du over 3x squared. Well, we notice we have x's and u's now, but the x squared over the x squared divided by x squared is 1, so it simplifies out. We still have to take the integral. We haven't taken the integral yet. We have 1 over 3, which is 1/3, u squared du. So again, we started with something more complicated with the correct u substitution, and it ended up being something much simpler. But we haven't taken the integral yet. So to take the integral of 1/3 u squared du, the 1/3 stays in front. To take the integral of u squared, we add 1, which is 3, divide by it. Don't forget your plus c. We take the integral, I should end with a plus c. 3 times 3 is 9, so we have 1 over 9, u cubed plus c. But we don't want our final answer in u, we want it in terms of x. So instead of u, we put x cubed plus 1. So our final answer is 1 over 9, x cubed plus 1 cubed plus c. Okay, we'll do one more. So we have the integral of 3x e to the x squared dx. Now it's complicated because I have 3x times e to the x squared, that's one problem, and I don't know how to take the integral of e to the x squared. I know how to take the integral of e to the x, but I don't know how to take the integral of e to the x squared. So our u is going to be x squared. Two reasons. One, e to the x squared, I don't know how to take the integral of it, but if it was e to the u, integral of e to the u is e to the u. Also, the derivative of x squared is 2x. That will end up in the denominator. The x and the x should simplify to make my problem even easier. So u equals x squared. The derivative of u with respect to x, du over dx, equals the derivative of x squared is 2x. So we have du over dx equals 2x over 1. Cross multiply. Dx times 2x would be 2x times dx. Du times 1 would be du. How do you get rid of times 2x? Divide by 2x, divide by 2x. Dx equals du over 2x. So we're going to substitute in u equals x squared, and we're going to substitute in dx equals du over 2x. So our problem, again our original, the integral of 3x e to the x squared dx, instead of, we're going to have integral of 3x, e, instead of x squared we put u, and instead of dx we put du over 2x. And like we mentioned earlier, the x over x is 1, so it simplifies out. So we have the integral of 3 over 2, e to the u, du. 3 over 2 times e to the u, du. Still haven't taken the integral. So to take the integral, the 3 over 2 stays in front. The integral of e to the u is e to the u. Don't forget your plus c. We don't want our final answer in terms of u, we want it in terms of x. So we have 3 over 2 times e to the x squared, because u is x squared, plus c. Okay, and then we'll have some more examples in the next video.